Today we're looking at transformations of functions. Your essential question is, how do I transform functions? Your learning intention, I'm learning to transform functions. You have three different warm-ups. The first three, actually it's five different warm-up problems. The first three are identifying which of the following are functions and then explain. So pause the video and at least identify which of the following three are functions and then explain why. Well, I do hope you tried. If we're looking at functions, we're focusing on our input values. As I look at this, I'm looking at the x value. None of them repeat, so this is a function. Because x does not repeat. Okay, what about the mapping? What do you notice? Well, -9 only has one line. -5 has one line, and 1 has one line, but 7 has two. What does that tell us? It is not a function. And why? Because 7 is mapped to 1 and 7 is mapped to 4. So it is not a function. What about that neat little S-looking curved graph? If you're looking at it, if I'm trying to pass that vertical line test, does it pass? No, it does not. So this is not a function. Does not pass the vertical line test. Okay, now pause the video and evaluate these functions. We know what f of x is and we know what g evaluated with x is. How do we apply that knowledge? If I'm looking at g, here's g. If I'm looking at what my x value will be, here is my x value. Plug and chug, you're going to substitute in. So 2 times -5 minus 7. 2 times -5 is -10 minus 7. So when I take my function g and I put -5 in for x, my answer is -17. Now what? Well, this time I have f. What's my x value? Well, my x value is -3. So, x squared, -3 squared plus 2. Okay, -3 times -3 is +9 plus 2. So when I take my function f and I use -3 for my x value, I get +11. A blank is a change in a position, size, or shape of a figure or graph. Well, we're talking about transformations. We're going to split this into two different types. There's one type that just moves it around on your graph. It can move it up, it can move it down, it can move it side to side. There's two different ways you do it, but if we're looking at transformations that affect the range of the graph, if I'm starting with f of x, that's my original, and I've transformed it to become g of x, what have I done? Well, it's moved up how many? 1, 2. To move it up 2, what would I do? I would take f of x, whatever that number was, I would add 2, and then I would get g of x. Adding 2 at the end will move it up to make it g of x. Okay, so we're going to look at the tables. We're going to graph the functions on the same graph, but we're going to fill out the tables first. So if it is x squared, h of x is x squared, negative 3 times negative 3 is positive 9, negative 2 times negative 2 is positive 4, 1 times 1, negative 1 times negative 1 is 1, 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. Let's graph that one to begin with. Now these are going to be symmetric around the y-axis. So it makes it easier when we get ready to draw the graph. And this one is h evaluated with x. Okay, what happens if I subtract 3? So I've got negative 3 squared, that'd be positive 9. Positive 9 minus 3 is 6. Negative 2 squared is 4. 4 minus 3 is 1. Negative 1 squared is 1. 1 minus 3 is negative 2. 0 squared is 0. 0 minus 3 is negative 3. 1 squared is 1. Minus 3 is negative 2. Do you see a pattern? This one would be 1. This one would be 6. And if I put... So I've got my pattern going on. I've got negative 3. I go up 1, 2, 3, 4, 5, 6. And then I've got negative 2. I'm having a hard time seeing this. And 1. I need to actually move this out because I got it. This is negative 1, negative 2. This one would be negative 3. And then I go out to negative 1 and I go down to negative 2. And then this is 0, negative 3. Then I come back up and I am able to do that symmetry. And this one is J evaluated at X. So what do you notice? The graph has moved down 3 units. Okay, state the rule. Okay, what happens when you add or subtract at the end of the graph? When you add or subtract at the end of the graph, at the end of the equation, it will move up or down. In other words, it moves horizontally. Okay, what happened here? I've started in the middle and it's moved to the left. The graph has moved vertically, and that would be 2 units. Okay, so first one was up and down, add or subtract at the end, moves it up or down. That's pretty self-explanatory. But let's see what happens when we add or subtract inside parentheses. So we've already done x squared. I can just rewrite it from the top one. I can regraph. Okay, here's my original graph. But what happens when I add or subtract in the middle? Okay, so -3 minus 3 more is -6. -6 squared is 36. -2 minus 3 is -5. -5 squared is 25. -1 minus 3 is -4. -4 squared is 16. 0 minus 3 is -3. -3 squared is 9. 1 minus 3 is -2. -2 squared is 4. 2 minus 3 is 1. -1. -1 squared is 1. 3 minus 3 is 0. 0 squared is 0. Okay, so have I started repeating yet? No. What would happen if I do 4? 4 minus 3 is 1. 1 squared is 1. So when I've got 4, I've got 1. Okay, so now I see the pattern. When I have 5, I will have 0. When I have 6, I will have 1. No, when I have 6, I will have 4. And when I have 7, I will have 9. Okay, let's go over here. 0, 9. So this is 0. I go up 9. 1, 4. Go over 1. I go up 4. 3, 1. 3, 0. 2, 1, 3, 0. 4, 1. 5, 4, 1. This should be 5, 4. Got off a little bit there, didn't I? Because 5 minus 3 is 2. 2 squared is 4. And this next one should be 9 instead of 4. If you caught that good, you should have told me. 6 to 9. Okay, now I want you to take a good look at this. I subtracted, but which way did it move? I subtracted, but it moved to the right. So is that what you would think? No, that's kind of counterintuitive. So, when I add or subtract, inside parentheses, it will move vertically opposite of what you expect. Now, so we've learned to go up and down, you add or subtract at the end. That's pretty self-explanatory. To go right or left, you put it inside of the parentheses, and it is opposite of what you expect. So these are horizontal and vertical transformations. Forgot the F there. Before the F, I needed an S. Okay, went out of the box a little bit. I'm coloring outside the lines today. So, get some practice done and make sure you understand how.